Hi, my name is Alan Ross, and this is a power panel from APC Media. It is sponsored by Iris, and you'll hear more about that later. My guests are Mark Paul, who is the head of global everything that it relates to market facing for Iris, and Cassandra Rounds, who is from Arizona Public Service. And there's a little bit about them coming up next, but thank you both for joining me.
First, thank
Good
you.
to be
Happy
here,
to be
Alan.
here.
Thank you.
So first, Mark, tell us a little bit about your background.
So I started as electrical engineer in the automotive industry, and I realized very quickly that the automotive industry was a fun industry. It was rapidly changing at the time, and I just realized there had to be something more than just being in a plant and doing, day-to-day whatever popped up activities. And so I ventured out and eventually went into sales with General Electric and really cut my teeth in, the personal interaction of what sales encompasses, and then moved over into Siemens. Got a different perspective on large corporate sales and the impact of customers and how to interface and do the things that were required on a daily basis. And then after some time with the major big corporations like that, I wanted to go off on my own and try my own hand at sales and doing different things as far as business goes. And so did everything from manufacturing to distribution to leadership development and sales training, and really had a lot of fun helping other people succeed in that arena. And after years of doing that, I got the opportunity to come work for Iris. And we'll go into that a little bit more later, but it's just been an amazing journey of working with tremendous people, doing amazing things, and being more excited now about what the potential has in business and in today's economy more than ever. And so very exciting times to be a part of this industry and working with individuals like yourself and Cassandra.
Excellent. Thank you, Mark. So there's a little bit about Iris Company. We're going to have more on that later in the webinar, but most people know Iris. Iris has probably changed the safety factor as it relates to arc flash more than any other company I know. Next, we'll get to Cassandra. Cassandra, thank you for joining us. APS is well known for many of the things that you all do in this industry, but share a little bit about your background at APS.
Yeah, for sure. So yeah, hello everyone. My name is Cassandra Rounds. I'm a senior engineer at APS, Arizona Public Service. Been working there for 14 years as an engineer. During that tenure, I've had several opportunities to move throughout the company and work in different departments and do different roles. Currently, like I said, I'm a senior engineer in the underground engineering and design department. So I always say what I do there is I build the grid. So I'm actually building the infrastructure that delivers power to our customers. So I'm out in the field and working in construction sites, and I get to go across hill and dale over the state to do this. And then I'm also installing everything underground, so wire and conduits and things like that.
Excellent.
Right now, I guess we go. So yeah, Arizona Public Service, like I said, it's the state's largest and longest serving energy provider. We are over pretty much the entire state of Arizona, so our service territory is huge. We are, committed to delivering safe, reliable, and affordable electricity to our nearly 1.4 million customers across Arizona. We also have a new clean energy initiative. We're going to be carbon neutral by 2050. We actively support our communities here through different programs and things that assist customers with energy needs, as well as outreach and charity and things like that. So it's a great company.
Excellent. I didn't know that Arizona had hill and dale. I mean, I didn't think there were hills.
I know.
There's
And
massive
trees.
monument hills, but it is a lovely state. I've been there many, many times. So let's get right to it, because we're going to talk about something that is near and dear to my heart, and that is DGA monitoring. And excuse me, I'm sorry. That's another one we're doing. But we're going to talk about the words resilience, reliability, sustainability, and then we're going to add some more to this. And the first thing I want to do, Mark, let me get you to start off for us. Every word has meaning in different contexts, right? I have a certain understanding of what the words reliability, resilience, and sustainability mean, but yours might be different. And from an engineer's perspective, if all of us could think like engineers and think like engineers are listening to this, define reliability, resilience, and sustainability. And you notice I changed those orders up because there, you'll hear about that. Go ahead, Mark.
Alan, you are asking a very dangerous question, how engineers think, and that is, that's why I claim to be a recovering engineer. I'm trying to think more of a normal way as I approach things, but in reality, how engineers think is incredible because we break things down to the very basics, and then we do things and design things to help others have a more productive life.
Right.
That's really our goal.
See, and
And
that's why I keep sucking you back into because what was that thing about they keep pulling me back in? I try to get
right,
out, keep pulling me
yeah.
back. Right.
Yeah, it's a world that you just can't get away from. After you understand how to learn, study, and then produce from that way of thinking, it's in my opinion invaluable. Others may disagree, like my wife, but I digress. Let me get back to the question that you asked us. What are really reliability, resilience, sustainability? What are those from a perspective of an engineer? And I want to keep it really focused on the electrical side of things today because that's where our discussion lies. And it really is different depending on what area you're talking about. Every piece of life, really, you could talk these 3 points and say, hey, does this make sense? And how do these work in, whatever that example may be? First off, I want to say they're all interconnected. So one really is dependent on the other, and if one is not built correctly, then it does impact the other two. And so let's talk about reliability for a minute. Reliability, as far as electrical distribution goes, is really the ability to deliver consistent power of an acceptable quality without interruptions under normal operating conditions. And so the reality is, usually you don't have normal operating conditions 365 days out of the year. So for the most part, reliable power is just of an acceptable quality without interruptions, without it dropping out. And that's reliability in the power grid side of things. Very important. And the average consumer, that's what they're looking for. They don't know anything other than, hey, my lights are flickering, or why is my appliance humming? I don't think it should make that noise. They don't know anything more than, hey, I just want everything to work. I turn on a light switch and I have light. That's what their concern is. So reliability to them is very basic. Resilience is another way of looking at things with the systems being able to withstand and adapt to recovering rapidly. So when things do happen, how do we get back to that state of reliability? How do we get back to that? I turn the light switch on and the lights come on. They want the ability to, no matter what happens, I want power back within 2 minutes. That's what the consumer's thinking. So when the power goes out, people are okay until it doesn't come back on. And that resilience piece of that is where people get very nervous. The phones start ringing at the power companies and they're like, hey, I've been without power for 3 minutes. My life is over. So it's true, right? I mean, people have a very small tolerance for things not being resilient. And so,
The thing today is I can't charge my iPhone.
oh, exactly. My phone is dead. I need to plug it in, right? So we need to be more resilient with our batteries and our phones, I would say. But here's the last piece, sustainability. And sustainability is really meeting current energy needs without compromising the ability of future generations to meet theirs. And we need to do this through looking at the environmental impacts, the ability to provide continuous utilities, and the ability to provide increased demands, no matter what that is. And so maybe we're talking nuclear, or maybe we're talking solar. Like there's a lot of alternatives that help us become sustainable. And when we look at those alternatives, some have more resiliency than others, some have more reliability than others. But that's why all three of these, reliability, resilience, and sustainability, are all tied together and interconnected.
That was really good. Now, Cassandra, I don't know how you can up that, but as a public utility, you got to represent these three on behalf of APS. Go ahead. Your thoughts.
Uh, I was gonna say, Mark, that was really good. You left me no crumbs to work with almost. Um, I'll do what I can. Yeah, I'm kind of the same way. Reliability, resilience, and sustainability, all three of those definitions. Um, I agree with reliability is just when I hit that light switch in my room, will the lights turn on? Can I have that confidence in APS, in my power company, that they're generating the power that I need, that I want when I need it, in the quantity and to the right quality that I need it to do what I need to do? Resilience, same thing, just our ability to resist outside negative impacts to the system, whether that be changes in operations to weather, right? We have climate change, environmental impacts, like in Arizona, we have wildfire risks. Our hill and dale that I was talking about earlier, we do have mountains here with trees. I know everybody thinks it's just a desert with cactus, but we need to have a resilient system that can withstand and make it through our wildfire seasons. And sustainability, yeah, just making sure we are using our natural resources in a smart way, in a conscientious way, whether that be natural gas or solar or nuclear power, as well as our materials that we use. Um, are we are we installing things and utilizing things and designing things in a way that can minimize the amount of materials that we use while also meeting those reliability and resilience um, standards that we need to meet as a company? So yeah, I agree with all of those. And here at APS, we're definitely dedicated to all three of those. And we have a lot of programs and a lot of initiatives in place where we focus on all three of these.
Well, your position in going through undergrounding is happening everywhere now. You mentioned forest fires. PG&E went through a bankruptcy because of a fire, and now they are spending 10 years worth of revenue money that they normally would spend. They're spending it every year to get things underground. And I know Ben Lance, who you know very, very well, is passionate about it. So he keeps dragging me into the undergrounding world. Uh, so let me ask you a question, because you come at this, you're Mark's customer. I mean, Mark's company provides for the industry. You are that industry that his company provides for. Many times the two don't meet. In these terms, you probably meet more clearly than in any other thing. So talk to me a little bit about um, when you see, is your approach different uh, at APS when you think of resiliency, reliability? This plays to right what you're doing today. I think you were about to say before I cut you off that the last thing you were doing, you were dragging cable through somewhere. But talk a little bit about it. What does it look like practically from your side of the equation?
Yeah, so things I'm working on right now that speak to this, like I can just use a example I'm working on right now. So like right now, the major thing that I work on is I'm the lead underground design engineer for Sky Harbor International Airport. So I
Mhm.
get to work with a really great Tiger team to work with that customer. Sky Harbor is one of APS's most critical accounts. It's a major hub for the valley as well as the whole state. So I always say, no pressure, but we'll get it done. Um, but yeah, so as far as that goes, I mean, one thing we do is we work super closely with that customer. Our planning department works with that customer. We're in weekly meetings with them to determine their needs, their goals, their future goals. I can't go into detail of what they're planning, um, but we're definitely looking ahead and saying, what are they planning? What are they looking at next year, 5 years from now, 10 years from now, 20 years from now? What do they want to do? What's that going to cost? What's that's going to take for our system? How are we going to implement it? How are we going to pay for it? How are we going to maintain it? So really working closely with that customer to look ahead and plan accordingly so that we can make a system that's reliable for them and resilient. Um, Also, right now, a lot of projects that I'm working on is going through there and through that um, campus, essentially, of the airport, and upgrading existing equipment. There's a lot of like older equipment or old circuitry that's there, old circuitry nomenclature. So we're going through and looking at different spots and saying, let's upgrade this, let's replace this equipment, or let's, just get different equipment in there. Let's upgrade this wire, everything like that. So really staying ahead of that and planning ahead, um, being proactive in working with our materials and seeing any new materials, new innovative technology that's out there that could assist that customer so that they stay up and that airport stays running 24 hours a day, 365 days a year. Those are two big things that I work on with that customer right now as I stand at APS.
I imagine you, when two events happened, one of them was the Atlanta airport shut down because of something that happened. That was maybe 4 years ago. And then, of course, the Heathrow incident that just happened last year. And the big airports that had major problems had to keep you up at night because you thought, "Well, that could happen here, that could happen here." But it's also good that it happened somewhere else and it didn't happen to you. It is critical because you just hit a point. You're trying to serve your customer's future. And that's what I like about APS. You're very forward thinking. You're thinking about what could, what that's to me a major point of resilience. Mark, you supply people both at the customer level, like at the Sky Harbor Airport, and to APS. So lives in both places that you supply customers. Talk a little bit about what it means to you as you're a vendor into the industry.
So I love hearing what Cassandra is saying because their company is being proactive. And unfortunately, many companies don't feel that they can afford to be proactive. They have so many must-do todays. There's no time to be proactive. We have to keep the power on today. And it's really unfortunate. So what the word choices are that a customer uses can tell you a lot about their thinking, about the leadership of the organization. And so another word that Cassandra used was, and she mentioned this yesterday when we had a brief conversation, she talked about the tiger team. And a tiger team is obviously someone who's, just they're on it. They're aggressive. They're making things happen. And so once again, word choices tell a lot about what's behind the scenes. And as a customer, whether it's the end user or the people, the OEMs providing the product to the end user, the thinking of the leadership really determines so much of the long-term reliability, resilience, and sustainability of the end user of this equipment and eventually the end customer. And so as a company, our tagline is engineered reliability. And so upfront, we are by design making sure our products do what is necessary for the end user. And that requires a lot of forward thinking, a lot of planning ahead. It's staying ahead of where trends are taking us. Like we're seeing this massive demand in the marketplace for more and more energy all of the time, and that's fantastic. And you can produce eventually you'll produce more and more products to be able to meet that demand if the demand doesn't get too crazy too fast. But even if you produce all this equipment and implement it properly and have phenomenal engineers like Cassandra making sure that things are being installed correctly and planned for correctly, if you don't have the ability to be able to do any kind of monitoring of that equipment, if you have no ability to be able to go in there and inspect the equipment on a regular basis and do things proactively to make sure things are being maintained when appropriate, then eventually you're going to come across the problems and we'll talk about some of these later. You asked that we discuss some real life situations that have been an issue because of the ignorance of all three of these key points. It causes some real problems and is financially very detrimental to all involved.
Yeah, well, later is now because we're going to talk about that now. But before we get there, I want to kind of wrap up some thinking about it. Reliability is making, as both of you have described, it's keeping things running. It is maintaining the equipment. It is the lights come on when the lights come on. The tower at Sky Harbor, it works. The computers don't go off because that's what's supposed to happen. But in a world where things are changing rapidly, if you're in the Houston area, for instance, they've had, I think in the last 5 years, they've had 3 hurricane impact events, and many of their substations were under 3 feet of water. Now that's two things. It's a substation, electricity underwater, and you've got to have a truck roll out there to do something. I guarantee you they wish they were underground, right? And so the same thing where there are fires, I guarantee you they wish they were underground. And so consequently, we see at APC Media, reliability is keeping things operating, as you said. Resilience is knowing that things are going to happen. You're able to recover as quickly as you possibly can. So you designed resilience in. So it's not just reliability designed in, it's now resilience designed in. I do this thinking that something's going to happen. If it never happens, guess what? We've had insurance. If it does happen, we don't really look that good because the public still thinks we should get it back on in 2 minutes. But we know we've done a good job of being ahead of that curve. And we're having to be, as Cassandra, you said, there's a lot going on, even in Arizona, fires. And I think the last year, you in Colorado had some pretty major fires. All we heard of was California, but there were some pretty major fires going on throughout your state. And you do cover a lot of more remote state. So you're going to have, you're going to have a substation up in the mountains somewhere that has problems, and you've got to figure out how to manage. You got a very complex thing to manage, not just Tiger. So reliability and resilience, from my perspective, are two sides of the same coin. Then you add sustainability, and I don't know where it goes on a two-sided coin, but we'll figure about that later. Anyway, Mark, you mentioned the idea of what happens when it doesn't happen. We're going to both go, you're both going to go into what happens when it doesn't work, with no company name, please. No human being shall be named. And if it's something that is other, like you're going to talk about the Heathrow thing, you can talk about names, the Heathrow Airport. But go ahead, Mark. Talk about what happens when you're not resilient and you're not reliable.
So I won't name names, and I appreciate
Okay.
you pointing that out because I try to do the same thing when I talk about previous employers, right? Like companies can have issues at some point, and then they make improvements, and they bring in new management, new leadership, and they say we're not doing this again. And no matter how good we pre-plan, things inevitably will happen, no matter how good the leadership or no matter how good the prevention, the design for reliability up front goes in. Sometimes things will happen. And that's where, okay, things will happen, but how can we bounce back from that? How is our resiliency come into play? 2018, there was a lot of fires in California. You kind of briefly mentioned this earlier, a lot of deaths, a lot of damage done to structures. The issue there was actually a lack of maintenance. Things weren't being done proactively to make sure that if an event occurs, if some things happened, how do we prevent, more problems from this happening? How do we limit the scope? How do we bounce back from these issues? So that was a real good example of something that happened in the electrical side of things, that began with some of these wildfires that happened because of a lack of maintenance in the power grid. Another situation was, you briefly mentioned this, is the 2025 hurricanes just in the Houston region. There was about 2.2 million people that lost power. And this also was from a lack of routine maintenance being done in the power grid. And so these things are occurring and will continue to occur across the country. And how can we be more proactive in doing that? And on the other side of things, one that you'll see the impact of all three of these, was it happened in South Carolina. There was a major nuclear expansion taking place. And in 2017, they actually had to pull the plug on it. And so they spent $9 billion up to that point before they pulled the plug. And the idea was, how can we be proactive, right? How can we look forward for sustainability for this region that we're going to cover? We need to add some more nuclear capabilities here. And so they had some pre-planning thoughts in play. But the reality was they didn't have the right resources backing all this. They couldn't think about enough of what might happen if things went wrong, or if construction costs escalated and time took longer than anticipated. They didn't have enough of that foresight. And so here's what that did. It's currently impacting the ability for them to supply reliable, consistent power currently, let alone what's going to happen the next few years as the demands keep growing. Their resilience is that, okay, they put $9 billion into this site, and now they're still not going to get any power coming from that. So how do we now, how do we pivot? What's the resiliency plan? And there wasn't one in play. So now that's hurt. And then sustainability. So not only do we lose $9 billion, and who does that end up costing? That ends up hurting the end customers, right? They're the utility buyers, the utility customers are paying some of that bill. So it really impacts a lot of people in a lot of different ways and really hurts reliability, resilience, and sustainability. These are just a couple examples. We could go around the globe literally and talk about real things that have happened in different parts of the power system that have impacted you and I as end consumers because of a lack of one of those three things being addressed on a consistent basis to prevent future problems.
That's really good. Cassandra, I don't want to steal any of your thunder, but we had a utility issue in Europe, and I'm not sure if the problem was in Spain that affected the rest of Europe, or it happened somewhere else in Europe and affected Spain. But we had that happen just this year. So it's different when a utility, and of course, we're not talking about APS, but you can talk about any other utility globally. Talk a little bit about what happens when there is a problem that's from a utility perspective. Mark briefly mentions the South Carolina situation. In Georgia, where I am from, we had I think it was a $5 billion overrun and 15 years to expand our nuclear facilities, which just came online this year in March. But that cost has to be taken up by the ratepayers, right? I live in Georgia. I'm going to see my rates go up to be able to fulfill something that we tried to do 20 years ago. Cassandra, talk about that a little bit. And I think you're muted.
Good. I think, can you hear me?
Yep, you're not muted.
Okay. Yeah. But yeah, just that as far from the utility perspective, when I think about that, the one example that comes to my mind is Texas a few years ago when they had that cold snap and they couldn't generate enough power. I forget, I think it was like 2021 or 2022. I think they had a really bad cold snap and they could not provide enough power for their customers. And I don't know all the details, but there were two points that when I was learning about it, they really stood out to me. And it's that Texas at some point had engaged in some, risk-based decision making. Somewhere at some point in time, people got together and they said, we're going to make a decision on how we operate and run our grid. And the decision that they made was to forego some federal regulations and federal guidelines, I believe from the Department of Energy, that would have helped make their system more resilient, more reliable, as well as it meant that they could not interconnect with the national electric grid. So what that means then is Texas as a state, that electrical system was isolated, right? So with APS, we do partake in those regulations. We do heed those regulations. And so we are interconnected with the national electric grid. We're interconnected with, I believe, PG&E. I should know this, all the points. I think Colorado. We're connected to our neighbors, where if something happens, right, we have agreements with them. We can tap them and say, hey, we have an emergency situation. Please deliver us some power. Whereas Texas didn't have that. So
Right.
that happened. It not only made they made a decision. They said, we're going to take this risk. We're going to do it our way. And we think that's going to work out for us. It's kind of like a gamble, right? In that case, when that cold snap hit, it didn't work out because then their system couldn't handle what happened. And then when the chips were down, they had no one to call to help them out. So people lost power and I don't know the cost of it. I remember even the fallout afterwards. Something happened with their rates too. People were getting bills for like $5,000 for the month or something like that. It was all sorts of chaos and things like that. So those are those kind of decisions, right, that utility can make for whatever reasons they had, but it negatively impacted the reliability and the resilience of their system. It was a big risk. They took a risk aimed right at reliability and resilience. And that's something, we've watched that happen and we've learned. And I'm really proud of the APS, like we have those, we follow those regulations and we're interconnected with our neighbors. So if something happens, we can still provide power to our state.
I think the ERCOT board was either they all self-resigned or the governor started over and said that obviously those decisions were obviously not good ones. One of the things that happened in the Texas grid, they are also their financial model is the less power they have to deliver, the more money they charge. So people who did not lose power, as you say, there weren't $5,000 a month. There were people that got $50,000 monthly bills. Now, eventually they worked all that out, but they certainly didn't pay the rate that they did prior to. So it's I think I call it the law of unintended consequences. And resilience is that you think about them. I mean, many of these disasters, we know they're gonna happen. And I want to go a little bit about and you're undergrounding, right? So you're undergrounding for a reason, to reduce the risk of an outage, to reduce the risk of a problem. Um, is that different today because we've seen so many things that, like wildfires, you cannot have Sky Harbor go down or any part of Sky Harbor go down? Do you think it's changed any from an engineering standpoint to maybe the bad, or I would say bad decisions that were made in Texas?
As far as our approaches
Yeah.
and things, I definitely think so. Like we definitely pay attention to what happens to our, fellow utility companies and um, address any issues. Again, that trying to be proactive, like it happened over here. What can we do to make sure it doesn't happen with us? Like the wildfires in California. I know right now we have huge fire mitigation efforts underway. Like fire mitigation, we're coming up with standards, with guidelines. We're looking at new philosophies, new equipment, undergrounding, if that's applicable. Up north, I know a lot of people say, like, well, the perfect solution is just to underground everything, right? That's a great solution, but you also have to balance it with cost, right?
Right.
So undergrounding is extremely expensive. I think the conversion is something like 2.5 to 3 times more expensive than overhead. So you've got to create that balance, right, with your costs, because otherwise that cost is going to get passed on to your customers. And we still want power to be affordable for them. So what can we do to retrofit our existing overhead lines? Can we do tree trimming? Um, can we use new philosophies, new technology, new supervisory equipment to monitor the lines, things like that? So we've definitely changed and been proactive and, upgrading our system to ensure that these lessons learned we see at other utilities across the United States and across the world, that they don't happen here.
Yeah. You set me up. You guys are great. You keep setting me up from, because I'm going to add two more terms to this. And you both talked about this term. And I was at a recent board meeting, and you were there, Mark, and we heard a number of people from the board talk about another. We asked the question of them, what's in the CEO's mind right now, the utility CEOs and the major supplier CEOs, and they used the word affordability. And they said, affordability is in the mind, in that mind. So you both mentioned doing it affordably, but we're going to talk about it a little more. And the other one is, we haven't mentioned it, but safety has always been an underlying. When we have done such a good job in this industry of reducing deaths and injuries from electrical shocks over the last 20 years, from before OSHA to now, we've done a tremendous job, but people still die every year from electric, and it's not people in houses, it's workers that are out there on the front line doing it. So safety and affordability are now two more terms. So as you talk about that, and you just kind of mentioned it, how do you bring that in? Because you can say to a customer, Sky Harbor, here's what we're going to do, but this is what it's going to cost you. And they can say, whoa, time out. Yes, we wanted to be risk free, but we can't pay that $1 billion to be risk free. Right now, the data center industry is going through that because they have to be, especially AI data centers, they need 99.99959 reliability. That's what they have to have. And then they come and find out the cost of 5.9 reliability and go, oh, that's a little bit. Can we get 99.993 reliability? And it's kind of changing a little bit. So talk a little bit in more detail about this whole affordability issue. Let me start with you, Cassandra, since Mark went first last time.
Yeah, no, yeah. I mean, that is a great question. I definitely see that day to day with Sky Harbor and other customers. Everybody wants the super reliable system. Everybody wants the Rolls Royce, but they balk at the price tag, right? So it's really about having conversations with your customers, understanding where they're at, and making sure you're describing the value in any upgrades, these changes, these costs, as well as maybe working with them to break up the pacing of the payments, anything like that, as well as going maybe from our perspective as engineers, going back to the drawing board and again, kind of that rather than upgrading, rather than doing something completely brand new, can we retrofit things? Can we just upgrade or improve things? Can we utilize different philosophies to increase that safety factor, right? They want this safe, it's reliable, it's resilient, but it's also safe for us. Um, but we can make it affordable for them. Um, Another example that comes into my mind is again like up north, everybody wants to underground everything, but it's too expensive. So one thing we do to our overhead lines that are out there is we introduce some new fire mesh. It's fire resistant mesh that we wrap around the poles. So if there was a fire to happen, the poles aren't going to catch fire and they're not going to fall down, right? Another thing with our operating philosophies, we have I have to look at my notes here. What do we call it? No reclose settings on high risk lines. So when we're in wildfire season on our overhead reclosers, right? If they see a fault on that line, they typically open and close. I think it's 3 times. They try to close back in on that fault. But in high risk areas during wildfire season, we say no, just open and stay open so there's no power on that line. Now we do have to incur a little bit of cost because now we have a lineman that has to go out there and visually inspect the line and look at it, but it's balanced with that safety factor with all these wildfires. And then we have, if people still balk at that, we have the case, right? California. We're like, well, look at what happened to California. Do you want that to happen here? And that goes a long way. Even with Sky Harbor utilizing, case studies, things that happen in real time. So like, look what happened to this airport. Look what happened to this utility. Do you want this risk, or can we work together to kind of like maybe make the price tag sound a little better, make it go down a little sweeter? So that's definitely something. It's a dance, it's a balance. When do you spend money to be safe, and how can you just be smarter with what you have now in the system, and upgrade things? So it's really a dance.
In a perfect world, there is no perfect world. So, Mark, any thoughts on that?
Yeah, it's what Cassandra said is so true. It's truly a dance, and it's really the discussion of cost versus price. And we go back to this all the time because people say, I don't want to spend X amount of dollars to achieve that level of security, safety, whatever it may be. But the real question then is, what is the cost? And so the cost, if you talk about just one life, what's the value of that? And if you were to save one life, if you were to save, in the case with California in 2018, 85 lives, what's that? What's the cost of that? And so you have to really be able to reframe it. And then you start talking about risk tolerance. Okay. At some point we have to draw the line. You can't just continually spend money on, unless it's government spending, it's typically regulated, right? There's only so much of it. And so we've got to at some point say, okay, what's the criticality here? What's the criticality of the asset that we're trying to keep safe? And so then you ask the question about safety. I love this because we've really rebranded our company to say that we are humanizing safety. And so for so long in industry, it's like, okay, you have to be safe, hard hat, protective clothing, whatever it may be, to provide safety for our customers that are interacting with these very dangerous pieces of equipment. So if you humanize safety, it allows you to have a different perspective on things. It's not just what does that cost me? It really goes now into, well, what is the humanizing part of that? What's a human life worth? How do we protect humans that are ultimately consumers as well as the people that are maintaining these assets? And let's look at all of that and put all that into perspective. And there's always going to be a trade-off. Always. There aren't unlimited funds. That's the reality of things. But there are levels that we can take things to that are realistic, that can be affordable. And that word came up very well in that meeting the other day, Alan, and it was really neat to hear the discussion that went back and forth. And you asked that day what my thoughts were, and I said, well, we always hear the new word soup of the month, the new word soup of the year. And so traditionally what happens is that we hear things all the way up the beginning, really at the highest level of government, and they start talking about things like clean energy, carbon footprints, things like that. And certain administrations have certain bents on those thoughts, and then you might get a different administration in and they say, drill baby drill. And so you've got these extremes that happen, yet the people in the trenches are still plodding forward and moving to keep the lights on, literally, for the customers. And so somewhere between the political swings that happen and the actual reality of what we want to make sure continually is the forefront of what we do, which is safety, humanizing safety, keeping things affordable for the end customer, all the way down to the person who is flicking that light switch on and wanting that light bulb to turn on in their house. We have to have every piece of that some level of safe and some level of reliability and some level of resiliency, and all of that, not just today, but for future generations. And that's the sustainability part. How do we do this not only for today, but how do we do this for tomorrow? How do we make sure our kids, our grandkids have the same conveniences as we do? And as we continue to consume, as humans do, our demands just keep getting greater and greater. I think back, I mentioned this in a meeting a long time ago. I said, back when I was a kid growing up, we did not have air conditioning in the house. We had fans, we'd open the windows. We had, we would sweat on the hot summer days. And now, we not only have, and we didn't even have air conditioning in our car. My dad said, we have 460 air conditioning. We roll the four windows down and I go 60 miles an hour. And so, now it's just about comfort, right? We want our seats to be cooled in our cars, and we have lights that shine up on the trees in our yards, and everything is powered. And it's just crazy, the consumption model that we're in. And that's not slowing down. We're just tipping the iceberg, because technology then allows things to be more affordable. This extra level of comfort and, easeability of life. Much of it's powered by electricity, which is great because this is the industry we all are in. And so we're in this, and we're excited about being in it because we do care. We care about people's safety. We do care about affordability. We do care about sustainability. All these things are part of what we do. And if we do it in an excellent way, then at the end of the day, we can be proud of what we've done. Will we make mistakes? Absolutely. Will there still be catastrophic failures? Absolutely. But even if we're responsible for any piece of that, if we knew we did our personal best to try to mitigate that, then that's all that we can do.
That's excellent. You just answered the last question I was going to ask, but Cassandra, you started answering that last question yourself, and then you set Mark up. Any other thoughts about what Mark was just sharing, Cassandra? Because then we're going to go to the questions from the audience.
Yeah, just kind of overall how important, resilience, reliability, sustainability is, and how it's made a positive difference in our system. It's in our blood. It's everything. It's what we need to be passionate about. Even sustainability. I didn't really talk about it much, but sustainability and how we at APS, at least, we diversify our generation resources and our generation sources. So like our clean energy, our carbon neutral goals, we're trying to diversify that portfolio of how we generate power, whether it's Palo Verde Nuclear Power Station, it's solar, it's natural gas, it's installing battery systems, BESS, battery storage systems. And we are on track to install about 2,700 megawatts of large scale energy storage by 2026. I mean, that's going to be huge for us as far as making things cost effective for our customers, as well as planning for a resilient and reliable grid for what's going on here in the state, because we are expanding. We are experiencing nothing but growth, nothing but almost breakneck growth. And we need to be prepared for it. So we're definitely planning for that, looking ahead and making sure we're taking care of our grid and our system and taking care of our customers and making sure they have safe, reliable power.
People are going to think that this was something we made up, but you just led into another question that and it actually came from the audience, which is great. But concerning, so I'm going to start with you on this, Cassandra, concerning sources like wind farms, photovoltaics, they don't add, but you added the other things. Now we've got geothermal and we've got nuclear. So we've got all of those. Is there already in the US a digital model adequate to guarantee secure system operation that you know of? So this is, I guess, for anywhere. Maybe the person who asked this question is somewhere where they have that model, but they didn't say. But do you know of an adequate system now? And Mark, you smiling, so you might after Cassandra.
Do you know? So a digital system, what was the
Digital
question? A digital
model,
system.
digital model adequate to guarantee, I think that word scares me, secure system operation.
So talking more of the security aspect. Yeah, and the guarantee does scare me. A
Yeah.
digital model. In my experience, which I don't know everything, there's a lot
Mhm.
going on in space right now. I am not aware of anything, but I don't know, like Alan was saying, Mark, you're smiling. Maybe you know something I don't.
Mark,
Well, I'm smiling because the only way that we're going to be able to provide for the future is if we think outside the box today. Now, even Alan, you were part of a discussion not too long ago with a gentleman in the data center industry, and we were talking about how the idea is to put data centers in space so that it accomplishes a couple of things that are being limited here when we put them on the ground, and that's the ability to for cooling. How do we keep things cool enough? It's such a massive resource draw with water consumption, et cetera. And so put them up where it's already cold, right? And so there's these ideas that seem crazy today that will be reality in a handful of years. And that's how we meet these things. We need thought leaders in industry is what we need. We need people that are willing to think, what if? Ask the questions. And are all of them realistic? Absolutely not. But some of the things that we do today, we didn't think were realistic 10 years ago. And so the demand, if you'd have told someone 20 years ago what the demand for power would be today, they'd have laughed. They'd have said there is no way you'll need that much power. And so things weren't designed for it. But here we are. And here, we're facing this. How do we meet the demands today? And it also helps us redefine what's acceptable. And so nuclear power was such a taboo thing for so long. It just became, I don't want it in my backyard. And I think still today no one wants it in their backyard if we had a choice. But the reality is that a lot has changed since 3 Mile Island, right? There's a lot that we've learned. There's a lot of things that we could have done differently. There's a lot of things that were blown out of proportion about what really did happen. And so based on new information, people will make new decisions. And when we help people make new decisions, then we can provide new realities. And that's really where I believe we can start meeting these needs is we start looking at what we can do with the technology that we have and the technology that we'll develop. And there are no guarantees in life except for taxes and death. And so those are my two things I stand strong on. But I do believe this engineers, as odd as we may be, we are the ones that create these amazing things that allow us all to enjoy more out of life. And so we'll figure out how to do it.
as unique as we are. That's a very good way of approaching it. I have a thought that engineers always run to a problem because engineers have by nature, we have a desire to fix problems. And so we don't run away from them, we run to them. We're like the Marines of problems. And I think that's why, Cassandra, what you're doing at APS fits in so nicely. This kind of is around that topic, but I'm going to add to it. There is a push now for these SMR, small modular reactors. And the data center industry is pushing for them because they want to place some near data centers, especially AI data centers. When you do a Google search on the phone, it uses X amount of power. When you make that an AI search, it's 1000X. That's why the power demand is so great, not just to cool the data center, it's the amount of power that you need to do an AI data search. And that's where we're moving to, no longer doing simple Google searches. Um, what is and you can't give away anything that you're not supposed to give away, but is APS looking at all at these SMRs, small modular reactors, either for because you have a lot of data centers in the Phoenix area, don't you?
Yes, yes, we do. We are a big hub for data centers, definitely. Um, and then, yeah, as far as looking into these, I'm sure you're right. I can't say specifics, and those teams I'm not really a part of, but I would say there is a group somewhere, probably several groups that, yes, research this and are looking into these sorts of things, like these smogs or other nuclear reactors or fusion. Um, to meet they're looking into this very, very, very seriously from an engineering perspective, from an investment perspective, the cost and the return on investment for this. Um, they definitely are. And I predict, this is my personal prediction, we're going to move in that direction in the future at some point because we have to. I just see it on the grid. I'm like, we have to do something like Mark was saying. Like, I agree with what he was saying 100%. Like, we need thought leadership. We can't do things the way we always did it before. Like when I started APS 14 years ago, man, if I had $1 for every time I heard we done it this way 30 years and we're not going to change, I'd have a Ferrari by now. But that I'd probably have a couple. But that's definitely changing because we have to. The future is now. Things are moving so fast. They're growing so fast. We need that flexibility and thinking. We need that passion for creativity, right?
Yeah.
And the bravery for creativity, the courage for creativity to think outside the box, as Mark was saying, to think these impossible things to meet our needs. So yeah, I think we will. I definitely think it's in our future at some point. Now where and to what degree, I'm not sure, but I'd bet on it that we have to be there. And we're getting the right people in now. I see probably in the last like 5 to 8 years, like that thought leadership, these people that are not afraid to question things. I mean, I always consider myself one of those people. Like, how can we do this differently? How can I think different about this? How can I challenge old philosophies or we can't do that? I'm like, well, who says? Why not? Let's go look out in the market. Let's go look at new equipment. Let's go look at innovative technologies that are happening. Um, let's challenge this and move forward. So I think it's coming. I see it. We'll just have to because we have to diversify our portfolio. We have to diversify our power sources. Um, so I think it's coming.
Thank you. There's an African word that I made up. It's from the first letter of that. That is the way we have always done it, Tetwade, right? And that's one of the things that 10 years ago was pretty big in the power industry. You don't hear that much anymore because people go, that is not the way we are going to do it, right? Which I really, really am glad. And I think that's because we are moving forward. I want to clarify one question. The question that came up about photovoltaics and everything was there was a blackout in the northern part of Brazil because the models were not representing the system adequately. Renewable sources models were not adequate. So they built in the physical system, and we've all talked about digital twins. And I think this
Mm.
is what I'm saying is if the digital twin does not model the real world, you're not going to be able to react to these kinds of things. So that's a great question. Thank you for the for Saulo. Thank you for adding to that. We've kind of hit our time mark right here. Thank you so much. This has been excellent. Mark, I want you to do something. Since Iris sponsored this, I want you to talk about Iris a little bit. So you give us an idea of how you said it a couple of times, but talk really about how Iris is making this a safe, affordable, resilient, reliable, what am I missing? Sustainable system of power.
Alan, Iris is a company that is not only a global leader in safety and reliability, but Iris really has some pretty unique, the core behind the company is this. We have a desire to fix problems. It's like you said, this is what engineers do. They run in when problems exist. And Iris was created based on needs of customers to do things more safely, more reliably, more efficiently. Martin Robinson, the founder of Iris, was the guy on the ground doing inspections and trying to keep the electrical world safer. And in that on the ground, hands-on experience, he realized that there were some real things lacking in the industry. And so he developed an entire company around helping the needs of the customer. And so when we talk about things like humanizing safety and fixing problems, I remember one of the first things that I heard Martin say was, we need to find out what keeps the customers up at night. And he said, no matter what the answer is, we need to help them solve that problem. Whether it's part of, our normal product line or not, we need to be the thought leaders that help find the solutions for our customers. And if we can be a valued resource for that, then they'll look to us for other valued solutions. And so we do provide solutions in the electrical space that allow people to do inspections more safely without having to open panels up, be able to do thermography, to do ultrasound readings, partial discharge. These are the things that are real issues in our power grid today that we can look at and do in a very safe fashion that allows us to create baselines so we know where healthy systems are operating. And then when things become, non-normal, when demand increases, when temperatures increase, when things happen, having condition monitoring devices in play, which is another part of what Iris does. We provide sensors and monitoring to be able to help people not only consistently watch what's going on with their systems, but also give them alarms when things aren't normal anymore. When those things start going from, reliable systems into systems that are starting to have some major issue happen to them. How do we provide resilience? Well, we need to find the problem before it gets major, because after a major arc flash event, the recovery times are large. And so if we can find when there's some partial discharge, which is the precursor to a complete discharge, AKA arc flash, if we knew that something was happening earlier on, then we could alert someone to say, hey, now's the time to address that instead of waiting until after the fact. And putting pieces into play like, infrared inspection windows and safe connect clips to determine if there's been a change in temperature above an acceptable range, or, putting in an e-Sentry system that is monitoring when we're all home at sleep. Like, those are the key pieces of what we provide to keep this industry not only moving forward today, but this is where, really the sustainability piece comes into play. If people are buying equipment without some of these things put into place when the equipment's being built, if you're not putting in, infrared inspection windows with ultrasound sensors on them when the equipment's being built and delivered, then later down the line, you will be putting it in. It's going to cost you more money. It'll cost your customers more money. And in the meantime, they're not going to be able to safely and quickly do inspections. And so you're hurting everybody. You're hurting the whole system by not putting some of these pieces into play now when you can. And that's what we help people do. And we like to be part of the design, engineering, and implementation of all of those pieces. And we do it extremely well. We're the best in the world at that. And we love to provide that resource for anyone who really wants to create a reliable system that has great resiliency, that has the ability to be sustainable long-term in a very affordable fashion.
Wow, you just covered all of my words. That's excellent. This has been an APC Media production. Mark Paul from Iris, thank you, and thank Iris for sponsoring. Cassandra Rounds from APS, brilliant. I'm recruiting you now to another part of what we do here. It's called Women in Power Systems. You'll hear more about that because you are an engineer, a women engineer in power systems. You're the gold standard of what we want to push forward, that it is a great time to be part of the power industry. When you were in school, it probably wasn't, because you're what, 21, 22 years old? When you
Oh,
were
you're
in
so
when you were in school, no, let me put this. When I was in school, electrical engineering, nobody wanted to go into the power industry. It was old, outdated, slow, sluggish, bunch of old white men with beards, right? Today, it's sexy because electricity around the globe changes the way humanity lives. I was just with the CEO of a major company that supplies the industry, and that CEO made the statement that electrification is what will save humanity. I didn't think I'd go that far, but he was pretty clear about his belief in that and his passion for that. Thank you both very much. This, as I said, has been an APC Media production. Here we go.